So firefighters have had questions about how operationally to fight fires on buildings with energized PV systems. UL in 2010 received a grant from the Assistance to Firefighter Grant Program to study just that. The first test was the shock hazard due to the presence of water in PV systems during suppression. UL conducted several tests using two different kinds of nozzles, a smoothbore nozzle and fog stream nozzle, and several different water sources: municipal water, pond water, and salt water. They directed a hose stream at a copper plate that was energized up to 1,000 volts and moved the nozzle closer and further apart to see at what point back on that coupling current was detected. What we found was that with a smooth bore, a 1-inch nozzle, 21 psi nozzle pressure, when 1,000 volts was on that plate, 5.7 milliamps was detected back at the coupling. When we went below 600 volts, that amount of current was lower than the perceptible level. 20 feet away, and there was no perceptible current at even 1,000 volts. So if you're only using a smoothbore nozzle, the recommendation is to maintain at least 20 feet away for up to 1,000 volts. However, as most departments do have combination nozzles, once the nozzle pattern was open to at least 10 degrees, the tests found that you could get less than 5 feet away from 1,000 volts. This was very helpful information for firefighters to understand how close they can actually get to an energized PV system and attempt to knock down the fire.